I welcome back all the participants to the FDP on bio-inspired computing for data analytics. Respected Dr. Dharavant Ramesh sir. Good
Yes,
morning,
yes,
sir.
I'm here. Yeah, I'm here.
Good morning, sir.
Yeah, good morning. So I think you're getting my voice, right?
Yes, sir. It's clear, sir.
Yeah, fine. Okay.
Uh, I request Dr. K. Anupriya Madam to introduce the resource person.
Thank you, Sherwani. Good morning, sir. It gives me great pleasure to introduce today's resource person, Dr. Dharawat Ramesh. Sir received doctorate from IIT Dhanbad. Currently, sir is working as an assistant professor in the Department of CSE at IIT Dhanbad. His research interests are blockchain and distributed computing, brain-computer interaction, virtualization and scheduling in cloud environment, big data mining, validation of machine learning strategies for big data, distributed databases, cloud databases, modeling big data, processing big data, virtualization and scheduling in cloud environment, load balancing approaches, deep learning strategies in cloud environment, community detection in large big data networks. Dr. Dharawat published more than 126 journal articles in well-reputed journals and more than 32 conference proceedings and more than 26 book chapters. Sir is currently guiding 5 research scholars, 2 submitted and 2 were awarded. Sir is currently working on 3 research-funded projects and 2 were completed from various funding agencies. Sir bagged so many awards and achievements like Outstanding Scientist in Computer Science in the year of 2018, Best Researcher of the Year in the year of 2018, and Empowerment and Equity Opportunities for Excellence in Science. Sir also organized various workshops, STTPs, conferences, and webinars. We are honored by your presence, sir. Thank you, sir. And
Yeah, yeah,
yes, sir. Now I request Dr. Dharawat to take over the session.
yeah. Thank you, dear, for giving a common introduction in a generic manner. Thank you. Then that is publicly available anyway. No issue. Anyway, knowledge is the metric, and if you have the utilization of that particular knowledge in a proper manner, definitely you'll gain anything. So there is the fund of success, right? Yeah. So let me share my screen. I think means I can observe 68 guys, including me, right? So do let me know. You guys are from various institutions, I believe, right? So any student community is involving here?
No, sir.
No. Yeah. Okay. Only professors, right? All professors. Great.
Yes.
Yeah. Let me share my screen and. Yeah, I think this is visible to you. Okay.
Yes,
No.
sir. Yes, sir.
Fine. Fine. Okay. Okay. Yeah, it's okay, guys. Today, I wanna share some prerequisites or a kind of knowledge, I would rather say, that is on some optimization strategies and self-swarm optimization algo, which we have recently validated for a real time application in cloud resource management as well as for agriculture specific application. So I'll let you know. Okay. Yeah. So my talk will go with some different modalities and probably that I may not go beyond, but let me give some knowledge from my end so that you guys can choose for your betterment really in a sophisticated manner. Yeah, okay. So this is the outline of my talk. Then I'll be covering the same as per the time schedule given to me. Yeah. So I'll give some introduction part, what exactly the optimization concept renders, and some types of optimization algos in different manner with their particular usage. And if time permits, then definitely I'll glimpse on the GA, and then I'll try to drag the concept of the exact optimization from the GA concept, and based on the same that I'll discuss the possibilities of utilized in the form of self-swarm optimization algo and I'll discuss the variants of the same and various of the same, and if time permits, I'll show you the compiled work up to some extent, right? And this is for today's work. And again, tomorrow I have the same session. There I'll discuss the exact application again with a different application in the cloud in IoT perspective. Okay, fine. So this is about thing. Yeah, that you guys might be having the complete knowledge about, and that my predecessors might have given knowledge to you, right? Anyways, that let me follow my own way. Then if any kind of repetition is happening here, then please knock me on the same so that I'll skip it, right? And meanwhile, you can interrupt me that if you have any specific issue with this particular point, so that I can clear there itself. Okay, so this will be a give and take policy. Why? Because time constraint is there from both the sides. Yeah. Anyways, so why we guys think about optimization process? What do you mean by this? Simple logic, right? Why do we really require the concept of this particular optimization? Right? Can anyone answer me, please? So that I can move. Otherwise, then again, I'll start from the scratch. Okay. At least one statement, one single statement answer that I'm expecting from your end. Okay, fine then. So let me start from the scratch. Then now I'm treating like that I'm also a learner like you, and that let us discuss. It's a kind of both the discussion happening among us. Yeah, fine. So here, the optimization is a process like making the system more effective. That in what sense? I'll let you know. By choosing a type of modality called optimal variable used for technical analysis. Please mind this point, my dear friends, that the optimization is complete depending on the two parameters, with two modalities. The first one is the optimal variable we choose, and it is used for technical analysis only. Right. So from this, definitely we'll gain much benefit. This is proved. That's why various combinations and various modalities, means various forms of optimization has been introduced. Okay, so let me start with one basic example. Say I want to buy a car, then my range is only 10 lakhs, less than or equal to 10 lakhs, and that it should be 8.5 lakhs to 10 lakhs, example. Say I have two constraints. The constraint is that, let me put some constraint that after some time we'll limit the same. Okay, that my car should be spacious. It should be spacious. Okay, and it must give good mileage. Okay, and the price must fit as per my wish. So what I try to maximize here, that my car must be spacious, right? And it must give good mileage. So that I'm expecting a kind of modality, right? I have fixed two variables here. That is mileage should be high, and again car must be spacious, means increasing, maximizing, right? Meanwhile, I'll try to minimize the same. What is that? I'm trying to minimize the price of the car. So minimization and maximization is happening based on this optimal modality, and this is used for technical analysis. So if I succeed the same, then definitely my wish will be fulfilled. Then I can go with different models, right? And I'll choose as per my wish. And again, let me include one more optimal variable here. That the variable it should be petrol variant one. Now, again, based on the petrol variant one, then that car must and should give required mileage. See, so we are performing technical analysis each and every time in order to get sufficient result. Okay, so it will definitely give us the accurate one. So that's what the concept of optimization process is considered in the real applications. Okay, so we'll see that. Then how can we make this optimization process success? Right, like, so various optimization process. See that I had mentioned that optimization is a process, not a specific paradigm. Okay, means process is combination of blah blah blah, something that we can include as per our wish. Just now I started with one variable, that is my car should be spacious, and the second variable was like it should be petrol variant, and the third one was like it must be having less price. See that even I can increase that. I'll go for 6 seats, 6-seater one as compared to 4-seater one. Then my price should be in between 8.5 to 10 lakhs like this. So how the process is becoming strong, that when we started merging the things with different options, then the process will means at that time the process is becoming more stronger, but it is also a time taken process, no, right? Because of this reason, different optimization algorithms have been uh, considered. So we'll see that. So what exactly an optimization algorithm processes or performs like. So as usual, an AOA optimization algorithm is a procedure, a simple, a kind of task execution type of optimality it gives, or a methodology it gives. Like an optimization algo is a procedure which is executed iteratively, okay, time by time, and up to some extent that by comparing various solutions till a satisfactory solution is observed and found. Okay, that's what we know. But what is the limit of this? This is the first question. So I'll solve this problem. And based on this, that this particular optimization algorithm strategy can be classified into two different types, right? So the first one is the deterministic, and the second one is stochastic one, right? Deterministic and stochastic one. Say the name itself giving the clear idea here, deterministic. So something should be solved within the deterministic time, and stochastic means beyond the range up to some extent, right? So we'll see the meaning of the same. So the first one says about that the algorithm concept or strategy which is considered under this particular deterministic point or part, right, are based on mathematical programming. That you know why? Because you know very much like without any mathematical programming, nothing is validated in the world. Do you agree? Yes, I believe that we cannot stay and we cannot assume the theory type of execution. It won't work. It is for framing of idea only. But until and unless you solve that particular critical instance by using
Excuse
a
me, sir.
mathematical programming model, yeah,
Sorry to interrupt you in between, but I can see there is just the first slide. Yeah, now the
yeah, yeah,
slides
yeah.
are open.
Okay, fine,
Yeah,
fine. Now
thank you,
this is
sir.
fine. Yeah. Okay, fine. So this deterministic algorithm says about like, so you must and should solve the modality which has been framed in the form of theory mathematically. Then only we can say that yes, this particular method is proved. Otherwise, there is no use of that, right? So the use means these particular deterministic algorithms use specific rules for moving one solution to other. Means you can make the hybridization concept, like say uh, for a bus engine, then I don't want to use the same bus engine. Let me merge this particular engine with two different car engines. Will it work? Definitely it will work. Then based on the parametric consideration, right? Like the size of the bus, okay, number of seats made available, right, and the weight of the bus, right, and the different number of tires fixed with that. Based on these factors, that we can assume the speed of the particular bus also. Let me merge one more. Let me merge with one more engine. So three car engines, three supercar engines have been means integrated in one part, and the stack is made available for bus engine now. Now you tell me, then definitely there will be a difference like this. So we
Sir.
Yeah. Sorry, guys. Kind of interruption happened at my end. Yeah. Do you hear me?
Yes, sir. We
Yeah. Yeah.
can hear
Sorry.
you, sir.
Yeah. This is the first time happened at my side, and basically we don't feel the interruption of power this time in our IIT. Anyway, sorry for the interruption. Yeah. Let me continue the same. Yeah. So we have started this point. So this is the modality that, okay. So we'll prove it mathematically. We'll see that. Then again, the deterministic algorithms concept are
Sir,
the
sorry to interrupt you, sir. Sorry, can you please project your slide, sir?
yeah, this is there, no?
Full screen mode, sir. Full screen mode.
Yeah, it's okay. Full screen mode, if I present, then what's happening? Then I'm not getting the point basically. So it is not giving me chance to change the slides. Why? Because this is
Okay.
PPT, not PDF. So
Oh,
let me
okay,
do
sir.
in the PDF, in the form of PDF, so you can wait for some time, for 2 minutes, then I don't have any issue. But the time
No
constraint is
problem,
there.
sir.
Now it is fine, right?
Yes, sir. Yes, sir.
Yeah.
But some text is
Now,
missing, sir. Can you please adjust? Yes, sir. Now it is
now
fine,
it's
sir.
fine, right?
Yes, sir. Please continue, sir. Thank you.
Yeah, fine. Yeah, so this is about deterministic algorithm. So what about the computation? Fine. So the modality was just now I spoke about, that can be formalized. Then if you propose model and if you try to examine it with different parameters, by including different parameters, definitely you can do it. I'll prove this. Okay. So the computation for this particular deterministic algorithms is based on a gradient of the response variable. Right. So what do you mean by gradient? Again, I'll give the answer for this. So these algorithms are somewhat difficult to model and may fail for non-linear and large-scale complex problems. Right? You cannot say like, okay, says this particular deterministic algorithm is going down. I mean, it's taken down for some problem, so it may not be considered. No, it is wrong. Right? So this is based on the usage. Right? So types of deterministic algorithms here declared, right, in the form of linear programming, non-linear programming, and mixed integer non-linear programming, etc. See, when I speak about the linear one, definitely it involves a mathematical modality. Where if I consider the dimensional reduction topic, then we people have the habit of using principal component analysis. So the PCA solves the linear description problem with respect to the dimensions. With respect to the dimensions, yes or no? So that's why. So without mathematical model, if it is considered, then there is no chance of performing, means there is no point of performing any kind of dimensional reduction on the data taken for experiment. So this is really difficult, no? Because of that reason. So every specific means each and every specific modality of any kind of algorithm is usable for at least a kind of thing like, okay. So the second part is that stochastic algorithm. So these are completely depending upon rules, means heuristics. So these algorithms are based on probabilistic transition rules. Now again, the part of mathematical is not avoided. The part of mathematical strategy is still considered. Okay, like probabilistic transition rules. Probabilistic transition rules we know, right? So it uses a randomness, like random variable. Just now I told you that instead of taking two engines, let me merge with a different engine. Now this time I don't want to merge the car engine with. I want to merge with, say, bike engine. Something blah, something x n number of cc engine. Now I'll check the modality of speed of the particular bus when I did with 3 different cars and when I did with 2 different cars with one bike engine. Definitely. So what are the rules framed? The rules framed for these two engines are quite different, where the car is having higher transparency in terms of speed and where the bike is not. Why? Because the bike's speed is limited as per the wheels arranged. Right? So that's what I want to say. So random variables kind of situation has been considered for stochastic algorithms. So these type of algorithms are more flexible and efficient than the previous one. But again, there is a point drawback that, however, this stochastic algorithm does not guarantee the best solution. Now you can ask me the question straightforward way. Right. The previous one is not suitable for some kind of problem, and the second one is not giving the best solution. Then what type of algorithmic strategy we need to consider? So we'll hybridize it, then definitely we'll make the possibility of execution somewhere. Right. I'll let you know. I'll prove the same again. So if you see the combinations of stochastic algorithms like heuristic methodologies, then we might have studied a lot many algorithms. So some of the algorithms I have mentioned here. GA. Why? Because I really like this algorithm. I started my experiments, hands-on experiment part with the GA. Okay. Then taboo sets, moved on. Particle swarm optimization before that. And I had verified the possibilities of all types of possibilities of GA, different variants of GA. Okay. And sometimes
Sir, sir, you are not audible, sir.
yes, sir, you're not audible. Yeah. So in this way, the concepts of stochastic algorithms have been determined. So I'll take the combinations of GA. I'll prove it. Okay, don't worry. So you know the concept of simulated annealing, I believe. Then again, we can merge the concept of simulated annealing and all to some extent, and we have other differential algorithms, evaluation algorithms as well. Each and every algorithm is having its specific uses in the application modality. It's designing the application modality specifically. Then again, let me clear one important point here, that all algorithms are not suitable all problems. Okay, different problems are different algorithms are suitable for different problems, right? And based on our convenience, we make it possible even by considering the combinations. Okay, so that's what I want to say here. So based on the strategy, the concept of stochastic and this deterministic algorithms have been designed, right? And people try very hard, really. So what is the importance of this optimization, right? The importance of optimization techniques are, these are used in every possible area of engineering today to get the optimal solution of the problem. So just now I told you, whatever the functionality you choose, whether it is a electrical functionality, mechanical functionality, or electronics functionality, instrumentation functionality, whatever the functionality you consider, including chemistry and physics and all, even that is possible. You make it possible, definitely. That I'm sure, right? So they are used to find the solution of many problems such as scheduling. So I'll knock on the same that I'm working. And planning means I have not worked on that. Resource allocation, I have worked. Right? Selection, I'll prove it that in what way the selection process will help us with the help of optimization, type of optimization techniques. So that is the importance of optimization techniques. Now, so before going to that how to solve or how to model an optimization problem. So what type of constraints we need to consider? Say for example, say I want to move from see Kolkata to Hyderabad. Then I have lot many ways. That let me consider three ways. That is by car, by car something, or by road, and by train, and by aeroplane. So let me optimize the things that, again, the price is my issue. Then I can afford up to something, some a number of means X number of amount. So let me optimize this one. So what the possibility is that I want to reach as early as possible. If I opt the flight, definitely I'll reach within the time, means within a short period of time. But my amount is not that much sufficient for that. So what we do? Shall I split the journey or something? Or shall I continue by train or something? Or shall I continue by road? Then it is up to me. So in order to manage the optimization modality, we need to have, means we need to consider three different types of constraints. The first one is that the variables, required variables, in other term I can call decision variables. So in order to formate the optimization problem, the first step is to identify the underlying design variables, okay, which are varied during the optimization process. Just now I told you that my price is varying. My price is varying, that if I could have chosen flight, then definitely that my price will go up to the range that beyond my limit, greater than limit. But I don't want to spend this. Right? What I do, that I'll split my journey. Half of the journey will be by car, and half of the journey will be by train, or half of the journey will be by train, or half of the journey will be by flight, something, or half of the journey will be car by, and half of the journey by will be something, right? Like this. See, so these are the decision variables. Fix it, optimize it. Now I have three variables and three different possibilities. 3 into 3, 9. So let me check up to what extent with my price, varying price. Say my price is fixed for, say, minimum it takes for me, individual, for an individual person, if I opt the train from my location to reach the destination, it takes, say, 11,000 rupees. Okay. Now let me vary the price starting from 8,000. Now what kind of best solution you'll get? Definitely will get based on the decision variables you have fixed. Okay. So this is the first constraint you need to consider. Now, the problematic instances on the name of constraints. The second one is the problematic instance, means these problematic instances represent some functional relations among the design variables. So what is the functional variability? The functional variability is that half of the time that I'll travel by car, right, and half of the time I'll travel by using train. See, functional relationship among the design variables, and I'll change the parameters as well. The parameter could be, say, I found one ghat road as compared to the highway, and ghat road is limiting say 10 kilometers. Definitely I'll choose it if it is good to travel, right? So this is another kind of strategy that we can impose, right? So it is up to us, that you may think in a different way to solve the problem in different ways, but choose the best one among. May not be, it is possible, but you can reach to the level, up to the level, at least optimal solution you'll get, not complete one. There is no 100% satisfaction you'll get in terms of solution, that I'm sure. Any kind of algorithm you use, that you won't get it. Otherwise, then why the modalities are changing time by time? Say, why different types of car engines are designed, why different types of bikes are coming in the market, why different types of modality in terms of computation has been happened. So we have moved from distributed computing to cloud, where the cloud combination became concept of distributed and centralized as well, but actual computation goes with cloud is centralized one. But beyond that, the distributed computing is happening, means it's a merging concept, no? Right? So something has been forbidden here. Something has been forbidden, right, in order to make the ambiency much more clear for problem solving. So this trick we need to absorb. That's it. So if you observe this kind of trick, definitely you'll become a good programmer and good model designer with optimization. Sure, I'm sure. Now, the third important point here is that the optimization function. You might have studied, and probably that you guys might have used this particular optimization functionality in our research up to some extent. But again, this is really a tricky and difficult question to solve. It is not that much easy. Just now I have spoken about like that my objective functions, I'm considering three, where that I want to maximize the space of the car, and I want to maximize the what's that, speed of the car, like means mileage, and finally third one is decreasing the price. So three variables I had considered. One is minimizing and two are maximizing. So how can I fix like? So this is called objective function. What is your objective function? That I want to maximize two variables and I want to minimize one variable, like this. So the objective function is formulated, especially when we consider the problem of optimization, right? In terms of the design variables that I have already cleared the concept, and other problem parameters. That the other problem parameters are that it is up to us. The tuning the parameters. So if you tune the parameters, definitely you'll get good results as compared to. So let me give one more example. So with the same three type of car engines, if I keep the size of the tires of the particular bus, then it will give the optimum speed as usual. Say mileage would be say 10 kilometers, something 3 kilometers per hour, 3 kilometers or something per liter. Okay. Now if I tune the parameters, say let me decrease or increase the size of the tires, what will happen? So this is the tuning the parameter methodology. So the common engineering objectives involve minimization of overall cost of manufacturing or maximization of total life of a product, etc. So the minimization and maximization combinations must be considered in the form of objective function, right? And based on your flexibility, right? If you want to change the objective function where the objective function is reaching to the optimal level, and you can stop it. Now, in future, maybe that the guys like me may verify your objective function and may perform some changes, right? May perform some changes and may improve the objective function based on their problem choosing. This is possible. That's what actually it happens in the research. Okay, so these are the three things we need to consider. So we have the constraints to solve the modeling and modeling optimization and solving the optimization problem. So these are must. Now moving on that I'm interested in meta heuristic algorithms, not completely in deterministic point of algorithms. Why? Because that I feel flexibility with this. I can code as per my wish. Then if I require, definitely I'll try to drag the concept which is being developed from the other type of algorithms. Definitely I'll consider it. But I'll not change this. I'll not change this. I'll take the part as usual, means I'll adopt it. I'll not change the originality, but accordingly I'll frame my idea, right? I'll frame the idea with respect to that functionality so that a new output will be generated. Okay, because of that reason, the meta heuristic algorithm concept I'll choose. That is as per my understanding. So the conventional optimization methods are, why? Because the conventional optimization methods are not much suitable, right? And these are non-linear and complex to design the problems. Okay. I cannot say like, okay, that non-linear problem cannot be solved or complex problem cannot be solved, right? And if the methods are completely conventional and traditional, then definitely we'll keep them aside. No, it's wrong. It's wrong. Take the time. Take the time. Why I'm saying that the functionality of the particular problem is really becoming non-linear. The functionality of the particular problem is becoming complex. In the sense, what reason? These are time-taken processes. These are the time-taken processes. Because of that reason, we don't adopt it. But some of the say that I want to make this server to be runnable and to be functionable for 365 days. Let it be. Okay, the functionality given to the particular server is that only managing the activities like storage activities. Whenever the storage activity is occupied, then it will perform read and write operations. That's it. So let it be. So it is a kind of non-linear and complex design problem, but we made it free and let the problem take the time. Okay, so this is another reason. Now, coming to the point of meta-heuristic approaches, these are very much popular from last 2 decades and really gained much popularity among the community guys. And these meta-heuristic algorithms give promising result on complex optimization problems all the time, but not again suitable for all problems. I cannot apply a specific meta-heuristic algorithm for different types of problems. No, it won't work. Right? So the meta-heuristic algorithm can be mainly classified into 4 categories. Now this is up to us to choose: evolutionary, swarm intelligence, right? And physics-based algos and human-based algos. That I have not touched, means I have not done any kind of work like with physics-based algos. That I have the hands-on with evolutionary, SWAM, and human-based algos. I can speak more. Even I can give you evidence as well. Fine. Yeah. So the types here are declared with their specified names. Like if I choose the evolutionary, that definitely I'll give the odd for GA. Why? Because the strategy of GA very much that I can tune the functionality of GA in any form. Okay, so genetic algorithm, differential evaluation, and evaluation strategy. That I have not used the evaluation strategy. That I have used up to differential evaluation up to some extent for the last work. Okay, coming back to the swarm-based algorithms, this I really like. And particle swarm optimization, that people are discussing that ant colony optimization, fire flea, and something gray wolf, and different types of algorithms. Algorithms came in literature and verified. Okay, now coming to the part of human-based algos like taboo search, teaching learning based optimization, and imperialistic competitive algo. Now coming to the part of physics-based algos, simulated handling, that harmonic black hole algo, blah blah blah. Lot many algorithms are there. I don't have knowledge, frankly speaking, about physics-based algorithms, but I can give some knowledge on evolutionary, SWAM, and human-based algos completely. Okay, so these are the types of algos. Now I have chosen, say, as per my understanding and simplicity and the easiness, because of the easiness that I have chosen meta-heuristic optimization. Why? Because here the heuristic in the sense combination of rules. You can frame your own rule based on your problem. That's why different types of car companies means gain the popularity in the world. Say Maruti is available. Why Hyundai is introduced? Then why the other car companies are introduced? What's the difference? Why? Because they have their own modalities in terms of different rules. So because of that reason, different car industries have been established like that. So the characteristics of meta-heuristic optimization are, there are two main characteristics of meta-heuristic optimization algorithm to ensure two solutions. That is, say, let me do. The first one is the local optimum solution, and the second one is the global optimum solution. And I'll try to explore the problem solving structure up to the maximum end, means exploration. So if I feel that yes, up to this time with this much of difference, that solution is observed, then I'll exploit that. I'll exploit that. So simple. I'm speaking in general meaning, in generic terms, so that I'm not going with some different technical words so that you cannot understand. That you are more than intelligent to me. I know that you can understand. So there are two main characteristics that we need to consider in order to solve and ensure the solution in terms of global and minimum, global optima or local minima we call basically, in order to perform the exploration and exploitation of the particular meta-heuristic optimization algo. Say exploration. What is that? In the sense, say up to the range of say 15 kilometers or something, 15 meters, my bike went with optimum speed, maximum speed, and it could reach the destination within the less span of time. Within the less span of time. Say my time given span time is say 15 seconds, say example, but it has reached the location less than that. So what I do? Definitely I'll increase the distance. Again I'll check. Now previously I have checked it for 15 meters. Now let me increase 5 more meters extra. I'll check it. Right? Again, if it is giving the same sufficient, less than or something less than or equal some, it will be different result. The different again I'll try to explore the possibility up to 30 meters. Right? So this is exploration. Then what about exploiting? Now if I feel that yes, that my combination is up to 50 meters, but I could not find the accurate speed when I reach the 35 meters. Okay, then I'll stop the solution. Then I'll say that yes, up to 35 meters, this particular bike will give the optimum speed required. So I'll exploit that. Clear? So this is called the exploration and exploitation strategy when we consider the meta-heuristic optimization. Now the second point is that simply I have mentioned here. See, exploration represents the searching ability to algorithms over the entire search space. Now that my search space is limited for 50 meters, limited to 50 meters, but what I did, I have limited up to 35 meters. Why? Because I got sufficient result up to that particular range only, right? So while exploitation is the ability to find the best solution near good solution. 50 was the 50 was the near solution, but I could not reach. So the best solution I have observed is up to 40 meters, 35 meters. So I'll fix the solution. This is the exploration and exploitation. So if we understand these 2 points, we can further tune the problematic instances of any meta-heuristic algorithm in order to solve any kind of problem, right? So this is the one of the characteristics. In order to make this particular exploration and exploitation concept much more clear and to be feasible, that a proper balance of both characteristics are required to obtain a good optimization performance. Good optimization performance. So one thing I can give you means one assurance I can give you here, like, sir, let it be. So let me decrease the optimum speed up to some extent, but that my destination should be high. So I can increase the capability of the particular bike up to 45 meters, but I cannot make it sure 50 meters. See, that's why a proper balance of both characteristics are required to obtain good optimization. If I satisfy, or if the industry satisfies, or the end user satisfied with this particular constraint, where instead of fixing the solution at 35 meters, that point is dragged up to 45 meters, then I don't have any issue, so that that particular product will be saleable in the market. Right? It is up to us. Right? You know how the Nokia industry led the environment. After that, how the Samsung industry led the environment. Now, who is leading the environment? No one is leading. Sharing is happening based on their best solution or best product released in the market. Best example. Okay, so this is the one. Now, moving on, let me start with the instinct, like how the basic idea we can get. Then, frankly speaking, the guy who want to start the research in this optimization algo strategy should start with genetic algorithm. This is my sincere advice. Okay, please don't run for a small data set, and don't limit the problem. Try to mix different types of variables, starting with one single two variables, like maximizing and minimizing, and do extract the same for adding by adding another attribute. Then definitely you'll get the knowledge in the same, right? Give the glimpse on this particular genetic algo with basic prerequisites, that in what way this GA will help us in solving the in making the methodology to solve a problem, a realistic problem. Solve a realistic problem. The things you know, the modality of genetic algorithm you know, but how to fix the constraints with respect to a specific problem is the important constraint here, means consideration, right? So I'll knock on this for just 15 to 20 minutes, and again I'll come back and I'll introduce the concept of the new paradigm that which I have mentioned, that is the self-sum algorithm. Okay, so for this reason that I'm closing this modality. Okay, yeah, let me share the another one so that you can understand it. Yeah, guys, do you hear me?
Yes, sir.
Yeah,
Yes, sir, yes,
fine
sir.
then. Okay. Yeah, just wait. Tab I need to select, right? No. Okay. Yeah, now it has come fine. Yeah, it's okay, guys. So these are the basic instincts of GA. That let me start with one basic problem. so that you can understand that how the optimization can be done in terms of mathematical simulation. So as usual that we know, it's a search-based optimization technique, ZA, based on the principles of genetics and natural selection. Now you tell me that a basic question, that genetic is not at all related to the real world things. Genetics are related to the human body, no? Then how the concept has been dragged, my dear friends? Right? You tell me. So some people say the butterfly algorithm. Butterfly algorithm. So butterfly is flying fine. Then how can we inspire from butterfly? Okay, birds are flying. So birds are flying fine. Then how sequence of the birds? You tell me then. So this is the modality of the problem. This is really a tricky one, no? That you guys are thinking like that, how the plane is moving by like a birds, like then how the moving instance can be situated, or the moving instance can be simulated by using the concept of one of the automation problem, making the automation problem. Like how this is possible? So I felt like this when I started with this particular GA. Okay, so it is frequently easy to find optimal or near optimal solutions to difficult problems up to some extent. I'm not assuring clearly, which otherwise would take a lifetime to solve even. Just now I told you, no, let the server to run, let it be like this. So lifetime to solve the problem. Sometimes some problems are there like that, no? Right. So a simple intro about that. Say as usual that as per the human being perception that I'm speaking, that we have the set of inputs for experimentation, that I'll fix the problem up to some extent, that what kind of process will it perform. Just now I told like I'm maximizing something, minimizing something. Okay, then again that I'm changing the modality of maximization and minimization. Let me decrease the price up to some extent, blah blah blah. Different types of parameters I have told about. Right, then we'll fix this strategy. This is called your block box thinking. Right, the guy who is having the block box thinking nature will definitely succeed in solving the problems. Okay, so process will fix it somewhere. Then I'm not specifying that what kind of strategies particular process embeds. And finally it will perform something and give set of outputs which we really want. Right, so here optimization is the process of making something better, not completely better. Okay, so what are GAs, that how the GA part has been considered to solve a real world problem. Like, so as usual that this problem is considered, means absorbed from the nature. So nature has always been a great source of inspiration to all mankind. Like GS are search-based algos based on the concept of natural selection and genetics. Genetics only. Genetics is the part of the body, no? Then how the concept has been dragged out? Again, that I'm getting a kind of shy feeling, like how the problem has been dragged out in the form of a transformation, strategy, so that a real world problem can be solved with that kind of traditional logic. Right? So we'll see the possibility. So the concept of the GA has been considered as an evolutionary computation part. Evolutionary computation. So as per my understanding, evolution means changing transforming something from one to another. Transforming something from one to another. A generic meaning as per the research modality I can give. So this is used for computation, no? Now, as I told you, the concept of constraint must be considered in order to frame a problem, and based on the problem frame, the solution may be designed with pen and paper. Right? We'll think in different ways. Like that I want to perform addition of two numbers, right? And my limit is from 0 to 1000, my dear friend. Right? Two inputs I will consider and one output. Two inputs and one output. A plus B is equal to C. Now you fix the timings. Starting with 0, 1, 0, 2, 0, 3, 0, 4, 0, 5 to 0 to 1000. Starting with 1 to 1, 1 to 2, 1 to 3 up to 1 to 1000. Right? Starting from 1 to many. Okay? 1000 to 1000 now. Now you tell me how many iterations you require. then really can you solve this problem if you put your hand with pen on the paper? Yes, you can solve it, but time is the limitation, no? So let us discuss the constraints for this. How can we fix this? That I want to solve this problem within 2 minutes. Within 2 minutes, yes, definitely, I can give you the answer by framing the modality in terms of code segment, so that the machine can do it, right? So this is the evolution. This is the evolution. So this is the greatness of our brain. So what are the constraints have been considered? These are the constraints. Please don't treat like that sir is teaching the topic again. No, please. These are the constraints, required constraints in order to solve a specific problem. So population. It's a subset of all the possible solutions to the given problem. So just now I told you, no, it's a subset of all the possible solution to the given problem. So my solution could be like this. Whatever the problem whatever the choice I'll choose, like whether starting from 0 with 1, 0 with 2, 0 with 3, 0 with 4, and 0 with 1000, this is the one solution. Starting with, again, 1 with 0, 1 with 2, 1 with 3, 1 with 1000, up to 1000. This is the second type of solution. Again, starting with 1000 with 0, 1000 with 1, 1000 with 2, like this. So which solution is the best one? Right? So this is population is the subset of all possible, means encoded solutions to the given problem. Clear? So this is one constraint fixed now. I have possible solution with me that I have worked on the paper. Now I need some representation, no? Representation. So one of the solution, let me pick. So I'll pick the solution as the started with 2, the 2 plus 0, 2 plus 1, 2 plus 2, 2 plus 0, 2 with 1000. So the same answer I'll get it, but the time sequence may be different as compared to the other solution. So I'm fixing this particular solution, and that solution I'm calling here it as a chromosome is one such solution to the given problem. So I'm treating the solution in terms of chromosome of the gene. Okay, clear. Now come to the point 3.1. So a gene is one element position of a chromosome, right? So I'm changing the positions. Let me consider two positions, like starting with 0. 0 is fixed. Now the second position will be changing, maximizing. 0 plus 0, 0, 1, 0, 2, 0, 3 up to 0,000. So a gene is one element position of a chromosome. I'm fixing something that let me consider the combination of genes with others. So third constraint. Fourth constraint is allele. It is the value a gene takes for a particular chromosome. So just now I told you, no, that I have fixed the chromosome. That is one of the solution with 2. 2 is fixed. And the second point that I'm varying, that second gene I'm varying 0, 1, 2, 3 up to 1000. So this is the allele. So the value is changing, no? So that kind of with that kind of value, the chromosome is fixed. Now later on, I got compromised, where that I have started with 2, but I could not get it within the time. So what I did, I have changed my chromosome sequence. Means the solution. That's what, guys. So this is your GA. This is your GA. Programming is possible. You can start with C language. Then later on you can change, but the logic must be strict. Logic must be strict. So if I could have used 27 codes or 27 lines, then one other person can do within 17 lines. Means the code is compacted in a strict manner so that the computer can understand, the machine can understand the sequence, and the same can be verified as early as possible. So the solution will come out.
Excuse me, sir.
Yes. So moving on. So just I have placed one simple illustration for your understanding. So that
Excuse me, sir.
Yes, please.
Population is a input.
Hello.
Yes, sir. Population is input. Can we call population as a population as an input?
No. Population is subset of possible solutions. No.
Okay, fine, agree. But it is
okay.
that.
Yeah. Okay.
The
so
input
this is the chromosome, and these are the values given 0, 1, 0, 1, 0, 1, 0, 1. So like here, the one of the sequences 0 will be considered as a gene. Now I can change the value as per my thing. See here, these are the population set of chromosomes. Clear? Population is the set of chromosomes. The solutions you can call. So you can change that. So gene 0 I had considered initially, but I don't know. Let it be. So later on, let me change the value. That if 0 is changing from 0 to 1 or something to, so it will become allele. Just now I mentioned it is the value a gene takes for a particular chromosome. Simple. So this is the way. Simple representation. Now coming back. Now again, some type of constraint. Having large number of constraints. But we can fix the solution. We can limit the problematic instance by considering the constraints. No need to consider, but the process must flow. So the genotype here is the population that what is the population had what is the population that I had kept here? The set of chromosomes. So let me consider one of the chromosome as a part, so that what will happen here? In the computation space, the solutions are represented in a way which can be easily understood and manipulated using the computation system. See, if I could have changed the sequence of the 0 with other ones, then definitely the the solution will be changing like this. So this is the genotype. We have the facility. Right. So within one template, we'll try to modernize. Within one fixed template, we'll try to modernize the sequence of chromosomes. Why this is happening? Say if I start working on the paper, it may take this many number of papers. It will become like bundle now. Yes. So this is the part one. Now part two. Phenotype is the population in the actual real world solution space in which solutions are represented in a way they are represented in real world situations. So this part may not be or may be considered. It is up to us. This is problem dependent situation. Now come to the part of decoding and encoding. This is must. Along with this population, chromosome and gene, allele can be included with the gene combination. No need to worry. That's why that you might have not heard about like this allele. So population, chromosome, gene, and other cross operation comes. That is what is that? Cross validation. It will come, right? So the decoding and encoding is a must is a must type of operation. So what it does? Now, what I told you that in order to solve the problem of this particular 0 to 1000 combinations of additions, what we did that we had fixed one particular chromosome, and within the same chromosome only we started changing the values. Okay, so how the same can be represented? So we have inspired from a type of problem and we are encoding the scheme into a particular real world format. So that real world format, we'll call it as encoding scheme. So for simple problems, the phenotype and the genotype spaces are the same. Just now I told you, that's why. Phenotype and genotype are same. However, in most of the cases, the phenotype and genotype spaces are different. This is problem dependent, right? The phenotype and genotype spaces are different. Why? Because if the problem space is increasing with different number of variables, then maybe the phenotype cannot be fitted. If again the good number of optimal variables are considered, then again genotype may not be fitted for this. So it is up to us. So let me fix the template in a real world manner. Then let me fix the complete template, a fixed template, so that just now that in order to perform the addition, how many I want to do? A plus B is equal to C. A plus B is equal to C only. I require this. Only 5. Where plus is fixed and equal is fixed. Now the values of variable A, variable C, right? A plus B. Variable A and variable C and C are changing. That's it. Right? So here again decoding is a process of transforming a solution from the genotype of the phenotype space, while encoding is a process of transferring from the phenotype to genotype space. Right? And as compared to the encoding, like keeping the real values and decoding the same, the decoding should be fast as it is carried out repeatedly in this particular genetic algorithm, the fitness value calculation, during the fitness value calculation. So what I'm doing here, my fitness value calculation is only one, my dear friend. That is, I'm increasing the values, maximizing the values. That's it. Only one single fitness function I had considered. So it may take maximum values. So this is the fitness function. So I'm not going to speak about this. Okay. Now genetic operations, like these alter the genetic composition of the offspring. These include crossover, mutation, selection operations. So these are the operations. So let me now solve a simple problem at an elemental level. Okay. So this is the bag given 15 kg. Right. So I have some items like a 12 kg item, 1 kg item, a 12 kg, and 1 kg and 4 kg like this. Now I want to fix maximum number of items. Maximum number of items, right? By fulfilling the space, by limiting the space of the particular bag. See, guys, that as a normal human being, let me think like the 12 kg I need. So that's why 12 kg, 2 kg, and 1 kg I have fixed. So 15 kg is gone. Right? I want more items. I want more items. So let me ignore 12 kg one. So let me consider the remaining 4 items. So now this is the dependency. Now you tell me. So that this is called knapsack problem. So this problem can be solved by using ZA. Let me increase the difficulty of this problem by adding more. And why? The parameter is considered is the price. Where that if I ignore the 12 kg one, then I'm accommodating 4 kg one. The cost of the 4 kg item is $10 here. Okay, this is the another parameter. So this is another constraint. So see, intelligence matters means in our human being language, if I speak, common sense matters. Okay, now let us start using the same. So it is up to us. The 1 kg item is having the price of $2. Now the 12 kg is $4. Now you tell me, let us optimize the same. Which one you should pick? That if you have the natural tendency, definitely you go with a normal operation. But let us optimize. So here 5 items are there. Then how many solutions will be there? Right? So it derives its name from the problem faced someone who is constrained by a fixed size knapsack and must fill it with the most valuable items. So that is the solution. Now you do solve from your end. So in order to solve this problem, this particular genetic algorithm follows these many number of steps. Okay, as I told you that let me fix the population initialization, one of the solution for me. Now the fitness function would be like this. Then up to some extent, whether I want to decrease the price, I want to increase the price, or I want to decrease the weight of the particular item, or I want to increase the weight of the particular item. So that is completely dependent upon me. Okay, so the fitness function calculation we have discussed. Now we'll change the functionality. Like say in the chromosome, the next slide, yeah, I have shown here. In the chromosome, what I did, I had considered 2 chromosomes. Then I am interchanging the values. Initially, I had considered 12 kg, 2 kg, and 1 kg, 15 kg filled. Now after that, in a second chromosome, I had considered these 4 items. These 4 items. So let me replace. Why? Because see, this 2 kg item is 1 kg item is costing $2, and here this 1 kg item is again costing $1. As compared to the same, the 4 kg one is costing $10, where the 12 kg one is costing only $4. Now let me change the functionality. So what kind of solution I'll get? So that I'll do from the crossover. Now mutation I'll discuss. Then finally the survivor selection. So what kind of best solution or optimal solution I'll get with this particular idea. If not, again I'll go back, I'll change the fitness function calculation, again I'll start performing the crossover and mutation, again I'll come to the survivor selection. Again, if I'm not satisfying the same, again I'll go back. So the loop until termination criteria is reached. Okay, so at one particular point I got satisfied and I fixed the same, and finally let me terminate the program. That's what I'm speaking in theory, but performing is not that much easy, my dear friends. So a simple genotype representation I have shown here, that is a binary representation. So 0010111001 up to some extent. So real value representation of this particular is containing 0.5, 0.2, 0.6 something and something. So let's see that. So integer representation happened like this. So this is 1, 2, 3, 4, 5 to something, and I'm fixing the values up to 4, right? And permutation representation is like this up to some extent. Now moving to the GA population. Population is a subset of solutions in the current generation. So set of chromosomes we consider, right? And population initialization happens in 2 ways. That random initialization is possible and rule-based initialization possible. That is up to us. Now, what about the population model? Steady state and means generational, if up to us. Mostly we people prefer steady state. Okay, but big problems that if you want to increase, if you want to club the GA concept with other one, definitely you will choose means generational. That I did with. I'll show you. Okay, yeah. So what is the fitness function? It takes a candidate solution to the problem as input and produces it as output. Fitness function. So the objective is to either maximize or minimize the given objective function. We have already discussed this one. Now see, here the item number is 0, 1, 2, 3, 4, 5, 6, my dear friends. The chromosome is considered with respect to the item number is like this, and the profit values given are like this. For this 0, this is 2, 1 is 9, and 0 is 8, something, and weight values are given like this. So here the knapsack problem was what? Here the knapsack capacity is 15. Okay, here the total associated profit is, if you consider it is reaching item, no, this I don't want. Say basic example. Now let me change the chromosome functionality with the by changing the item number. So it will give us the solutions. So if you solve the problem like this, now let me fix the fitness properties against the proportionate selection with a kind of root wheel selection, this is the part of the GA you might have studied, then definitely we'll get the functionalities of the solution in different ways. In different ways. Like chromosome A, one solution, B, C, D, E, F, some up to 6 solution I had considered, and the fitness values I got here is that, say, for A solution, that particular chromosome 8.2, 3.2, 1.4, 1.2, 4.2, 0.3. Now you tell me which one is best. Which one is best? You choose among, and accordingly that you need to justify. Excuse me. You cannot say like, okay, that sir, I got 0.6, the best one, fine, great, but no, but you have to justify why that you have chosen 0.3 only. Why not 1.2? Why? Because the parametric consideration is quite much easier as compared to the solution given in terms of solution given for F in terms of 0.3. No, so you must and should justify it. Otherwise, community won't accept. Community won't accept like this. So this is the parent selection situation, the stochastic that I'm not discussing at this moment. Now see, this is the another selection. The first one is the roulette wheel selection. This is the one situation we can consider under the DA, and the second is the tournament selection. The same problem can be solved with this kind of selection, right? And this tournament selection is performed based on the rank selection, right? The idea is available. Now again, after choosing whether kind of selection, after choosing the selection type, we will come to the crossover operation. So just now I told you, no. So let me fix the crossover functionality with the chromosomes like this. So this is 1 point crossover, my dear friends. Only 1 point. So 0, 1, 2, 3, 4 and 5, 6, 7, 8, 9. Right? And this is the second one, second chromosome, 5, 8, 9, 4 to something. Now see here 0, 1, 2, 3, 4 as usual. And here I'm changing this modality one way. That this 5, 6, 7, 8, 9 comes down and 3, 5, 7, 5, 8 goes up. Now again, perform the activity. Perform the activity. What kind of solution you'll get? You can get. This is 1 point crossover. Let me increase multi-point crossover. So this is 1 point, 2 point, 3 point. So 0, 1, 2, 5, 8, 9 I'm keeping constant. Now let me change the functionalities of 3, 4, 5 to 4, 2, 3 and 6, 7, 8, 9 with 2, 5, 7, 5, 8. Now let's see that what kind of functionalities we'll get. It is up to us. Now uniform crossover, another type. C. So how many types is supposed to, how many times and how many types is supposed to do with, and the code segment need to be fragmented like this. So is it really looking similar and easy? No, I don't think so. So once you put your hands on with the different modalities, then definitely you'll be convinced. Oh, GA is really having good structure to solve a specific problem until and unless you do, right? So in this way, the crossover functionality can be taken. Now, coming to the part of mutation. So mutation means easy to maintain and introduce a diversity, okay, in the genetic population. So mutation operations are lot many, guys. So bit, flip, random resetting under swap mutation will come. That you know the meaning of mutation, just now I discussed. So just fixing the values, right? Scramble mutation, inversion mutation, that you can try with. Okay, it is this code is available in the C also. Now, another kind of selection is also available under ZA, that is age-based selection. Age-based selection. So this we can do. So this is one of the popular strategy. Another one is fitness-based selection. That mostly we prefer this one, right? Why? Because each and every time we need to check with the new population. Because of that reason, the fitness-based selection is chosen. So this is very easy to understand even as compared to age-based and this tournament selection and the related selection. For bigger problems, related selection will be the best choice, I believe. Okay, yeah, and finally the termination condition comes. So when there has been no improvement in the population for X number of iterations, and when we reach an absolute number of generations, when the objective function value has reached a certain predefined value, we'll stop the operation. Now, even I cannot say. Why? Because I have chosen a specific problem that, and you have chosen a specific problem. So will it be work that if I frame the same idea for these two different problems? Obviously not. And my iteration level could be up to X, and your iteration level could be up to X plus N. Okay, why? Because the problems are different, my dear friends. So now let us drag the concept. Let us drag the concept. One concept we need to, means one theme we need to observe from this. What is that? That is exploration. That is exploration. Means what is the maximum limit to consider the iteration possibility? I'm speaking technically, my dear friends, not theoretically. So what is the maximum possibility to drag the iterations to find the optimal solution? So that is not fixed here. Okay, so exploration is a drawback of GA. Now, okay, based on the exploration, exploitation is possible. Why? Because I'm fixing the same that I'm not satisfying. Let me run two different algorithms like GA and particle swarm optimization, where PSO is giving the time less within the less time as compared to ZA. Now I can means I can come to the conclusion. Oh, okay, these number of iterations are required if I choose the modality of PSO. Why? Because the modality of PSO is similar, more or similar to this GA, but the functionalities will be changing like this. So this is completely depending upon the theme selection inspired from the modality of the representation as presentation. Okay, so let us based on this one, so let us go back to solve the same problem of this particular optimization with one of the newly introduced paradigm called I have yeah introduced, that is self swarm optimization. Okay, so I'll tell you the reason that why the concept has been considered. Okay, please wait for a while. Uh, yeah, some disturbance is coming, my dear friends, from your end. Please limit it. Yeah. Yeah, okay, I'm sharing it again. So I'm coming back to the actual strategy that we are going to discuss with the concept of the same. Before going to that, let me conceptualize the concept of this particular GA with other applications as well. Okay, yeah. So this is, yeah, is this visible?
Yes, sir.
Yeah, fine. See, now you can ask me that people are really scary, and people are having enthusiasm towards newly developed technologies. So in today's scenario and today's means world, that people are chanting AI, artificial intelligence. So this is a subset that, let me speak in technical terms like that set space is AI. My entire set space is means artificial intelligence. Under this, again, I wanna deploy two different subsets. That is under AI. Let me try whether it permits or not. Yeah, yeah, it is giving some representation for me. Let me represent. See, this is my set space, my dear friends. Okay, so I am treating this set space for computation as AI, artificial intelligence. Artificial intelligence. Okay, you know what do you mean by artificial intelligence completely. Now, under this, I want to deploy one sub task, means subfield. Again, this is called ML. Okay, machine learning. Now I can embed the possibilities of these optimization techniques under this subtask theme ML. Now under ML, I want to place another subtask, okay, sub theme, that is called DL, deep learning. Deep learning. Now, if we treat AI is the branch, now ML is the sub branch. Again, DL is the sub branch of that particular ML. So DL will become sub branch and sub branch of AI. Now, what is the flow of execution? Starting from AI to ML or ML to DL or something? No, AI is the set space I told you. So, in what combinations? AI is equal to ML plus DL, or restricting the DL combinations up to some extent. So, there, under the concept of subtask or subfield of ML, that we can fix this particular optimization modalities. Okay, so that's why I mentioned like the architecture of systems that implement genetic algorithms are more able to adapt to a wide range of problems. So A genetic algorithm functions by generating a large set of possible solutions to a given problem. So this is called artificial sense, not intelligence. So in them evaluates each of those solutions and decides on a fitness level. This we have discussed. Finally, these solutions then breed new solutions, and that new solution we are calling today as artificial intelligence, not artificial sense. We are using artificial, means we are inputting artificial sense, and in the form of output we are getting artificial intelligence. So here the parent solutions provided by any kind of optimization algorithm that were more fit or more likely to reproduce, while those like what were less fit are more unlikely to do so before the introduction of artificial intelligence field. So in traditional computing, you won't see this, right? I'm the particular evidence. When I started, when I left the Infosys and start again joining the academics back, I could see the changes in the industry. People started running behind AI. Okay, so that point gave the rise to the technology, new technology, and we people are enjoying the technology, even sleeping with the technology, living with the technology. We really forgot to live our means enjoy our life. We are simply passing our life because of this. Okay, sorry to speak like this. Anyways, so finally, in essence, solutions are evolved over time. Different types of solutions evolve over time. This way, you evolve your search space scope to a point where you can find a best and suitable solution for a particular problem. So, in this way, the combination of optimization strategies have been considered. So now, again, beyond the AI, we are moving, no, right? So ML part that I am forbidding now. So ML won't involve with the neural network. So where the concept of deep learning comes with neural networks. Why? Because deep learning is the combination set out in the form of networks, right? So again, another sub-branch came in existence to solve the problem with optimization strategies. Sorry, by including the optimization strategies and by considering the optimization strategies. So evolving such kind of architecture of neural network is slightly more complicated, but there have been several ways to doing it. It gives again optimum result. Just now I told you, no, that I have stopped the chromosome sequence execution at one point. There, after that I could not find another point to move on. But what I did, I made the environment as hybrid. Then I started transforming the modality of the GA solution into the neural network. Say for example, now there I got the chance to move on, right? So in this way, the combinations have been framed. I'm not discussing about. So what exactly the evolving of neural networks gave the rise? So many would think that learning function could be evolved via genetic programming. This is wrong illusion. Just void it from your mind. Unfortunately, genetic programming combined with neural networks could be incredibly slow, thus impractical. As with many problems, you have to constrain what you are attempting to create. So this era evaluation of the justification started from the year of 1990, my dear friends. Okay, see, just now I had mentioned this particular David Chalmers attempted to evolve a function as good as the delta rule, and he got succeeded. Right? So he did this by creating a general equation based upon the idea rule with 8 unknowns, which the genetic algorithm then evolved. So the era was started in this movement. Then other areas like GS can be applied to virtually any problem that has large search space like AI. So I cannot say like that ignorance of the particular GA could be having the limitations and restrictions up to some extent. Again, wrong illusion. Until and unless you try, then you can say that this is not possible with this. Now you move on other time. Okay. Now moving on, that example I don't want to discuss here. Now keeping the structural framings, different types of structural framings of different optimization strategies, and finally we could reach to this level. This is the new algorithm that we have experimented and validated for two different problems. And I really felt that this algorithm is quite practical to implement. And one thing I want to make sure that this is not an individual implementation. Okay, the part of the variational part of GA, which has been embedded in the form of particle swarm optimization has been considered for some of the operations of this particular algorithm to make the execution strategy quite faster. Strategy quite faster. This we had considered. Okay, so I'll introduce, and you may find the similar methodology of the PSO, I believe, to some extent, but the PSO won't consider the exploration and exploitation up to the limit, and we can fix these two constraints. We can fix the modality of these two constraints up to the range if you follow these kind of optimization paradigm. Okay, blue whale algorithm. Okay, and grasshopper algorithm, spider monkey algorithm. Okay, evolutionary spider monkey algorithm. We have tested all. We have tested at most, but we could not find the suitability of these all for different problems. All common problems because of that reason. So you could means you can go through the publications of mine where different types of algorithms have been tested, and we are doing so for best experimentation and finding out feasible solutions for a specific problem. Okay, right. So we are moving to the new strategy that probably you might have heard about this particular algorithm, but the implementation point you didn't, I believe, right? Okay. So here, this particular SALP swarm, again, this is the swarm natured algorithm, but the combination is considered physically in the name of SALP. So SALP is one of the species of ocean or sea. Ocean or sea. We'll see that. So it's a type of swarm intelligence algorithm developed recently in 2017. Came in 2017. People started adopting it and optimizing with this, optimizing different problems with this algorithm. Finally, we did in 2000. Last year we did it, and we really succeeded for two problems. Really good, and it is very easy to code even. Why? Because we know the sequence of GA, and from there we have dragged the combination of concepts towards PSO. Again, PSO variants have been tested. It is very easy. From there, again, we have moved up to spider monkey, and spider monkey to again evaluation to spider monkey. Again, grasshopper optimization. Similarities we have checked, and finally, okay, that they gave good results. I'm not saying they are bad, means not completely bad, but the optimality we found was really fine tuned with this kind of strategy. Okay, so this is the conclusion I can give you from my side, because that I have tested it and validated it on hands-on. So here the SALP swarm optimization or algorithm. Okay, let me pronunciate it SSA. So this SSA mimics the swarming behavior of SALP in navigating and searching for food in deep ocean. Okay, so like spider monkey algorithm. Okay, where the spider monkey algorithm, what happens? The combination of groups will be framed, and after the segmentation will be done, and each and every segment will go towards the different parts of the search space, and they will search for food accordingly. This is really a good strategy to understand. But the global minima, the global searching option was quite high for the particular algorithm. Even it gives best solution. Okay, that was the reason. So that's why that we have moved to this particular algorithm. So again, the same concept has been considered where the monkeys are going for searching food. Okay, but here the SALPs are going for searching food in the deep ocean, and the deep ocean will be considered a search space. I'll discuss this point. Now, a SALP is a small barrel shaped. SALP is a small barrel shaped plantic tunicate that travels by shrinking. Okay, that travels by shrinking and pumping water through their gelatinous bodies. Okay, I'll show you the structure. So they form a spiral shape like this. They form a spiral shape colony of salps called a salp chain. Now, individual salps making a salp chain for better locomotion and foraging. I'm introducing one new point here: locomotion, and the foraging, and the compatibility behind this particular phenomenon is really quite good as compared to others, where the global search space concept is segmented for different algorithms, but here that is not segmented, that is transformed from one to one side. So the information processing became quite faster as compared to other algorithms, right? You know, the information processing, the main issue for any kind of computational strategy. So this computation strategy gives faster computation, in terms of information processing. Why? Because the search space is locally marked with optimum, with good number of SAPs. Okay, see, this is the concept. So let me maximize it. What happens? So this is a single salve, my dear friend. As I told you, this is blinking and dedicating something, right? Pumping the water and something, and it is searching for food. Say, let me say this is only taking grass type of food, and it's grass type of insects from the sea, ocean. Okay. So from the point, let me discuss individually. So it observes something, two variations. Three variations we'll discuss. We'll start with the first one. So it observed a food, a grass insect. Okay, it won't take it. It won't take individually. Why? Because the food available for this particular salp is not enough. Okay, this is one parameter. Now, it may get sufficient food even. It may get sufficient food. Now let me fine tune another parameter, that this is the mother salp. This is the mother salp. Now it is searching for its children. Now again, when the salp started sharing the food with the children, again what happens? It will become limited. Yes, again. So we'll think in that scenario. Now this is for gaining food. Okay, gaining food. Now second scenario, that it won't get food, no food available. Now no food available. Now it has to go. It has to search the space again. No food available. Two constraints. No food available means what it does. So will it stop here or what to do? Again, in the third step, that since that no food is available, now it will start moving around the search space of the particular ocean like this. Particular ocean. Now from this point, it started moving here. Okay. Now again, the same situation may occur whether finding the food or not finding the food based on that one. If it finds the food, now let me stop the criteria of this particular salp. So this is the salp now. Okay. Now like this, another salp also found food. Right? Again, another salp also found food like this. Now they will share. Now this search space will be entirely searched until they get the sufficient food. So now this is completely involving the n number of salps. So where now I want to mention one point here, that all salps may not get sufficient food. All salps may get sufficient food. Some of the salps may not get even sufficient food. No food. Right? So this is the set space now. So you tell me now, say how the situation can be barreled or handled. Really difficult, no? But see that the common sense is means giving some knowledge here. What we do, we'll share, we'll start sharing. If suppose say this got unlimited food, okay, now it will start sharing with the second one. Even this particular salp may or may not maybe or may not be having the food. So if it is having the food, again it will be preserved. Again, these both will share with the third one. If not, this third is not getting anything, right? Sharing is possible. Now, if not, again, then it will go for another one. Now, based on these three salts, let me treat like these are the three best friends, and these are the three salps surrounding this particular space of the particular sea only. Only three are available. No other salp is available. Now, then the criteria will be stopped here. Why? Because they got sufficient food for this particular time. So based on this constraint, let us frame the story. Hope you understand the theory. Good story, no? That it is like a story, tale story. But this is quite interesting. If you start coding with your hands, then definitely you'll feel difficulty. That is not that much easy. Yeah. Anyways, so to solve the optimization problem, the swarming behavior of the salps in the salp chain is mathematically modeled. As I told you that without mathematics, nothing is possible. So the SALP colony consists of two types of individuals, that is a leader and followers. A leader and followers. So election has been done. So again, in order to make the election, a separate algorithm will be chosen. So that I'm not bothering about. Why? Because in keeping in mind that one of the SALP should be the leader, whether it is a female SALP or male SALP, doesn't matter. Like spider monkey. In the spider monkey, female will be the leader. That is sure. It will lead the team. Yeah. So here a leader will be chosen that by keeping the assumption. Let us frame the story. So the first SALP in the chain represents a leader. Okay, that guides the movement of the SALPs in the chain called followers. So based on what? So as I told you, this particular SALP, number one SALP, was searching initially, and the remaining were idle, right? And at one particular set space in the C point, it observes some food. Okay, so automatically it will call others. It will call others. So other agents will come and join with the leader SALP. Now accordingly the chain will be framed. Now I'm not fixing the SALP size here. Okay, my assumption is that again the number of SALPs, my food is this much, the number of SALPs are this much, that I want to partition, and that all the SALPs must be satisfied with the food, like this. Okay, so the first SALP in the chain represents a leader that guides the movement of the SALPs in the chain called followers. Fine, as usual. Now the initial population of SALPs S is equal SALP 1, SALP 2, SALP 3 to SALP n is initialized randomly. Okay, n is the total number of SALPs. Again, clear? Now each SALP S is represented by a dimensional point. S is equal x1, x2 up to xd. So within these many number of dimensions that each individual SALP can move on. Where there is a number of decision variables in the optimization problem. Where if the particular SALP is not getting the sufficient food even after traveling longer distance, right? The longer distance is my decision variable. So what it does? So it is reaching to the boundary of the particular set space. No, it will come back, and the entire knowledge will be zero. I mean, entire computation will become zero. So in this case, that direction will be blocked. So this is a decision variable. So that longer distance made that particular SALP to return back freely without food. So that particular direction will be blocked. Now I'm simply speaking in direction, no, but how much time the particular SALP taken to travel that distance, my dear friends? So it comes under one computational strategy, no, that is processing. So we need to manage this again. We need to manage. So how can we manage? Say one of the SALP just moving 2 meters and it found food. Okay, so the range given to that particular second SALP is, that is the what's that? Group. One of the group SALP is minimized. So that particular dimension is subtracted from the one which not found the food. So the information processing average becomes possible now. So this is the strategy. Simple. Now different types of variables have been considered. Let's see that how the same has been solved with the mathematical notation. So the position of the leader is modified based upon the target food source F. Target food source F, which can be given as, say, x1 is equal F here. F is representing target food source in each space. Okay, let me maximize this for your illustration. Yeah. So this F is the target food source in set space. Right? And here, see, upper bound and some lower bound limitation is there for the set space. So as I told you, one of the SALP just moved 2 meters and it found some food. And one of the SALP moved up to the range, but could not observe the food, like this. So we have some upper bound and lower bound limitations based on the energy given, right? So upper bound and lower bound limitation is there for X1. I'm considering this is the one chromosome. Okay, you can read in your genetic algorithm language, right? So we'll see some parameters we are giving, that C1, C2, and C3 parameters, and we are maximizing and minimizing the range up to greater than or equal to 5 and 0.5 and less than or equal less than 0.5. My threshold value has been considered from 0 to 1 as per the interaction happen. Okay, where here L is representing the current iteration number. You can call our I, no issue. And capital L is representing the maximum number of iterations. Small current iteration number and maximum number of iterations taken. So as I told you that C2 and C3 are random variables. I'll fix the value for the best option chosen, where upper bound and lower bound cases are chosen for set space. So this nothing is different. It is very easy, right? So all
Sir, sir, not audible, sir. Sir, not audible, sir.
is it fine now?
Yes, sir. Now it is
Yeah.
fine, sir.
So yeah, so based on the
Thank you,
current
sir.
iteration and the maximum number of iteration, the functionality of this particular means variable will be considered. So these are the framings. Okay. Now continuing, for X, the position of the follower salves are updated as the average of nearby salves position, which can be given as I told you, that say one of the salve moved up to the distance, but it could not find the food. So that space will be minimized by adding to that. So the subtraction will be done, right? So point up to 6 meters that no food was available for one salve, where another one got within 2 meters. So the range was 6 meters for each and every salve. So now 4 is still left. So 6 minus 4, 2. Now again, we need to solve the problem of we need to adjust the 2 meter distance for the deficiency happened with one particular salve. Okay, so like this, the position of the same will be updated with the same, like this, where xi is equal to half of the particular xi or xi plus 1. Now the food possibility is streamlined with this particular application, where here z is representing objective function or fitness function. As I told you, for each and every optimization problem, there must be a fitness function, and here si is the ith salve. So after each position update, the fitness value of salve z of si is computed, and the target value of f is set as the position of salve with best fitness value among all the salves. Now the distance problem is solved, and my information processing will go as usual. Now, so in order to make the concept, that again, as I told you, some constraint we need to consider in the form of parameters. So what are these? The parameters are, as I told you, the C1, this particular parameter C1 plays C1 plays an important role in balance between exploration and exploitation. Okay, its value decreases slowly with increasing number of iterations. So the leader salve is responsible for exploring towards the food source F. Leader salve will decide up to what distance the follower salve should go. Okay, so the leader salve will take the responsibility in minimizing the distance if some salve could not find the food, like this. So while the follower salves are responsible for exploiting as their value updated slowly with reference to nearby salves. Okay, say that one is moving towards something, another moving nearby. So it may tell like, my dear salve friend, that I'm not getting food. What should I do? So it will tell that our destination is going to reach. Then if you could not find it, then revert back and update the same to the leader salve. So the leader salve will mind it, and the minus, this will become the negative option for the particular dimension. So that particular negative option will be removed by adding to the other positive salve distance. Okay, so this is the solution made, clear cut now. Now coming back, so this one, based on this story, the mimetic salve optimization studies was designed. So this is the, instead of considering one chain of salves, what we do, then we'll consider the combination of several salves now, chain, independent salve chains. Here I had considered only one. Okay, like this. Now let us consider these many number of chains up to n. Okay, so this is m number of chains now, like this. Multiple independent salve chains. Now there is a possibility of food sharing among individual chains as well. This is also the possibility. Exploration. Okay. Now in this mimetic one, instead of considering the global food source, local food source L are considered for each salve chain. Hence, the position update for leader salve M chain can be like this. See, tell me what is the advantage, my dear friends. See, if I consider the individual chain, the set space will be configured with the individual salve chain of individual salves of this chain only. But if the number of chains are increasing, what will happen? This chain also started foraging the same. This chain also started foraging the same. So the distance should be minimized, and food can be food can be optimized, means food can be found, and same food can be optimized instantly. So distance will be minimized, so execution time will be minimized. And this is the solution. So again, the same modality, no changing here. So L of M, I have changed only one, that best local fitness value of M spal check. This I have changed. C1 is common, C3 is common here, and C1 is same as equation 2 that I had mentioned. Again, the random numbers are changing from 0 to 1, nothing. So no change, right? So this is the solution. Now what is the application? This application that I have used for the feature selection in crop disease classification. Simple reason. Okay. So this is a feature selection concept that just now that one of my predecessor speaker was discussing about. So as usual, so feature selection is one of the prominent tasks in several domains such as pattern recognition, medical diagnosis, bioinformatics, and classification that we know. So this part that we had solved by using this concept. So feature selection using automation algorithm, just now I had explained. So this I have solved it. So the fitness function is the framing of fitness function is the important criteria for anything. So that's why the combination has been framed like this. See, the fitness function is composed of considering the classification quality and size of the generated feature subset as defined by, like, fitness function is equal to some parameters, where, see, gamma R of D giving the classification quality of conditional feature set R. Okay, see, I have mentioned a kind of representation. You can take A of B, no issue. This is your representation. I don't have any issue with that. Why? Because this is the configured situation. So I have exploited the same without any changing, but parameters I can change as per my wish. Why? Because this is my problem dependency. This problem can be solved based on my dependency, right? Because of that reason. So here again, the capital C has been considered as the total number of extracted features, and alpha is the weight given for each classification quality. The maximum value would be 1, and again beta is the weight for size of feature subset. And as you know that we mustn't choose to use any kind of classification that we have used KNN classifier, KNN sniper. Okay, tested with. So this is the simple flow diagram. The things which I have explained now that I put in the form of process, like, so starting from that number of extracted features, what I require. I want a specific kind of food, my dear friend. Grass, insect food. Types of grass, insect food would be there. But if I eat this much, if the salt eats this much quantity of food, then it will be satisfied. Okay. So the number of features will be selected: small size insect, big size insect, medium size insect, type of insect, like this, different features. So initialize the population of optimization algorithm of n dimension randomly as binary value. This is the common practice. Just now we had seen in GA as well. Okay, nothing is different here. Nothing is different. So now it comes to the actual part. It comes to the calculating the fitness value first. Okay, I'm discussing this point. I'll come back to the actual combination. See. So straightforward manner, I'm coming to the fitness function calculated by using equation 5. Just now I had shown. Now I have checked the iteration to the maximum number. If it is fitted by giving the best feature subset, I'll stop. Otherwise, what I'll do? I'll say no. And again, I'll update the position of the particular cell. What it represents? It represents that applying the transfer function to convert point position into the binary value again. So again, I'll submit the fitness value chain with the particular binary value. Again, I'll test the similarity of the same. So this will be repeated till I get the satisfactory subset value. Clear? So just now I have spoken for 45 minutes, no? So that concept is embedded within this code segment part. Within this code segment part, simple one, right? So moving on, what's happening here? Moving on, the same possibility, this concept is applied like that. I made it mimetic swarm optimization as binary one. Why? Because I had considered binary values. Okay, in this way. So the MSSA is designed to solve problems in continuous cell space, no limitation, until and unless the iteration is satisfied. So to perform better selection, feature selection, the continuous SAP MSSA is converted to binary. So these are the combinations considered for the same. So I want to mention only one important point, that each and every time that I told you know that transferring of dimension must be deducted. So that concept is considered that T of T is the transfer function, and the iteration number, and D is the dimension represent total number of features. Clear? Nothing is different. See, it seems like a mathematical equation. No, it is very easy if you understand. Okay, yeah. So finally, the location vector of vector of leader slab is still updated each and every time when it gets the information from the followers slab, right? In the same standard fashion applied in MSSA. So to find the average solution for follower salve position, a crossover operation. See, the crossover has been performed in GA. So GA is not voided here. Still, it is considered. So crossover operator is applied that impersonates the result between these two. So this is the limitation given. So for the follower solve, the position changes with equal probability of the obtained values and shown. This is the follower solve calculation. Position D, if it goes beyond, -1 iteration. That's it. Nothing. Now, so the classification concept has been applied again in a different manner by using the by developing the code segment, right, for binary classifiers of SVM for each disease. I'll show you just like this. So initially, what we did, the classification is executed without performing any feature selection. Okay, tasks are using all the features extracted in the feature extraction step. Here, the classification accuracy of 91 percentile and 88.33 is achieved. For, as I told you, that we are considered the crop diseases. So we have observed the same for 91 percentile for maize image and 88.33 for Gape disease data. However, the rice plant is achieved accuracy 66.66. So this we have tried for our Telangana region. We have the collaboration with Jayshankar Agricultural University. Okay, so this is a sponsored project basically. So then this particular MSSA optimization algorithm is executed over the 10 independent runs of feature selection. Finally, its performance parameters such as the best fitness, best accuracy, average fitness, and average accuracy, and an average number of selected features are calculated. So simple. So this is the one. So let me show what exactly happened with this particular algorithmic strategy. Okay, just permit me, give me some time so that I will show you. Okay, yeah. So let me share. Currently, that my screen is off. I don't know what's happening here. Yeah. So this one I want to show you because again. Yeah. So this is the work. Just now, see, I spoke in different manner, no? So this is the memetic salve swarm optimization algorithm based feature selection approach for crop disease detection system. So let me tell you the importance, my dear friends. I'm not saying it proudly. See, this is the new variant of optimization algorithm. Then I had submitted the paper. It's a 7 impact factors journal, you might be knowing. This is on 15 April 2021. See, after revision, only one single revision, then the paper got the acceptance in 12 July. May, June, July, only 3 months. You just understand, this is the new variant opted and examined properly. That's why the combination has been framed, and accordingly, the modality of this particular theme is modeled, and the same has been configured with the crop images. So structure diagram, proposed crop disease dissection method. So this is the code segment plan implemented for the idea, with the idea. See, as I've told you, like SVM classification model is utilized, and this is the framing of the algorithm. This is the framing of the algorithm utilized here. So that's what. So that is hard work is the only metric I believe, right? So unless you experience it, then only you can say something to the community, and even you can convince the community with the real time implementation aspect. So these are the configurations. Just now I spoke about this formula, no, gamma or something. Just the same has been depicted. And as I told you, this is the salve-sum optimization algo considered with different types of features. See, these are the features. So all features considered for the same. And as I told you, that each and every feature is having its own phenomena in terms of mathematical model, and everything is every model, every equation model is validated, right? So because of that reason, this possibility came, and this algorithm I have already discussed just now. Okay, then I'll show you some results. See, this is the single SALP strategy, and this is the algorithmic modeling, algorithmic model for experimentation part, and these are the equations I have already discussed just now. Okay, and these are the functions considered with respect to the binary mimetic SALP sum optimization for feature selection. Just now I discussed only variant of code that you can do, right? But integration is somewhat difficult when you do with Python and something. This is my advice, and be careful. And this we have tried with our cloud database. Why? Because we are having the individual cloud server, so that we can store and do accordingly, right? And I'll tell you the combinations considered for this. Okay, so this we have tested with the same with different types of data sets even. And yeah, comparison of the proposed binary MSS with other meta-heuristic algorithms. So different types of meta-heuristic algorithms have also been tested here, like this. So these are the variations of. I really like this algorithm. That is particle sum optimization. We have used the combinations of the same, right? But we have not ignored that one, right? So why? Because this is the good algorithm that which gives the flexibility for any programmer to code and model the possibility for any kind of given problem. So this is for maize data set. Okay, this is for rice data set, and this is for grape data set considered. And as I told you that we had calculated the accuracy individually for each and every data set. That's it. Okay, so this is publicly available. Hope that if you want to go, or if you are having any difficulty in terms of programming, especially when you frame any fitness function, that please do let me know so that I can help you. Okay, guys, this is about today's discussion. So I'll join with one more application which we have really fragmented for the cloud resource optimization problem. So I'll discuss with a specific solution with the same SALP sum optimization as an application. Then how the problem has been solved, I'll let you know tomorrow. Okay. So if you have any specific questions, please do let me know. And hope that I have maintained the time sequence. I believe 140 was the given time, and so still 5 minutes are left.
Sir,
Okay.
I have one. Sir.
Yeah, please.
Sir,
I have one question.
SARS algorithm for feature selection. There you have discussed about lower bound and upper bound for a candidate solution. So how to set the values for lower bound and upper bound, sir? Can you just
that is depending upon depending upon your set space. Okay, set space. Yeah, got it. See, set space, how can we decide? Tell me. Say that if I have small data, okay sir. Small data set space, then I have only limited number of features, so it will be very easy for me to aggregate. No, say for example, I have trousers, example. Then I want to match the trouser with the corresponding color of his shirt. Okay, as usual, only 5 I have considered. Then I'm searching for best suitability, right? So my range of that particular color is bright. So the value given is a 0.8. Okay, so I'll fix the values. I'll check the trouser with the shirt color accordingly. So this is very easy for me to calculate, no? So this is completely depending upon your set space. Got it? Set space is the number of features you choose. Optimize.
What's the range values for those features if it is different? Like suppose it is integer, for some features it is float or something, like different data types are there.
Yes,
then in that it should be common for all the features, or it should vary based on the data type?
No, that's why I told you, based on the data set. Say the data set, one of the data set you choose, right? This particular methodology won't be suitable, right? If you consider different data set. That's why I told you, no, this is the problematic instance. If I apply the same for disease infection, got it? For disease infection, then it may give in a different manner.
Okay, sir.
That's why I told this is problem dependent situation. You test it initially, check it from your end, whether the optimization function is possible for this particular data set or not. You check it from your end for at least a small data set. Then definitely will know, okay, it is possible. Then you start explore it up to some extent. Up to what extent it will go? Now, what you do when you increase the data set size, the different number of features will come. Number of features will be increased, right? Accordingly, yes, got it.
Yes, sir. Fine.
Good.
Thank you,
Good.
sir.
Yeah. Okay.
Excuse me, sir.
Hello, sir.
Yeah. Please, guys.
My question is, you implement the algorithm optimization algorithm in the two parts. Like first, you evaluate the minimum fitness value, and after that, for the minimum fitness value, you select the set of features, and then you apply the machine learning methods, or you can focus only the accuracy.
No. Accuracy.
So your
Yeah.
objective is accuracy. So I am not clear about that, sir. In few papers I have seen, they are focused on the accuracy, and some other papers they are focused on the fitness. After that, they apply the machine learning models. So I am very
Exactly.
confusing.
No. Second one is the
So
right.
please, sir, please clear about it.
Yeah, second one is the right choice, my dear friend. Don't choose the first one. Don't go for accuracy directly. Okay. Second one is the best choice.
No. First one is, sir, first we have to select the minimum fitness value, and after that, for the minimum fitness value, we have the set of features, and then we apply the machine learning models on those features. Or
Then after we go
second
for accuracy.
part is, yes, sir.
Yeah, then after we go for accuracy. Don't do it instantly.
After
Because see, yeah. Are you getting? Excuse me.
After that, we go for the accuracy. Accuracy.
Yes. This is the exact. This is the right following strategy. Please don't do that. Don't check with accuracy directly. Say for the existing.
Okay, sir.
Yeah.
Then if according to you, if I will go for the minimum fitness value, so second, my question is, sir, how can we set the objective function, and which first objective function is just like accuracy TP plus TN upon TP plus TN FP plus FN. So this is the objective function for the accuracy, like this. So if you want to set the objective function for the minimum fitness value, so there are few examples that you can show, sir.
Okay, I can
You
show,
have
but
objective function.
yeah, sure. Say, let me consider there is no problem with single objective. Why? Because it gives straightforward results. Okay. Now let me consider the second. Yeah, let me consider the second option. Second option is that one is maximization, one is minimization. Okay. Now in this way, what you do? So now you check the possibility. Now you check the possibility of maximizing the value up to some extent. No need to worry about the minimization. Why? Because the minimization you have already set. Now accordingly you check the accuracy strategy with the proposed algorithm, right, with the limited values for maximizing the sequence. Now when the maximizing sequence is started giving the values, you'll find the similar values of minimization. If suppose based on the maximization values of similarity, if the minimization is completely going and fixing up to the level, then you'll stop the criteria. Then you'll find that at that particular point, say let me fix the threshold value up to 0 to 1, where at 0.77 I got the good accuracy. Then I'll stop it. This is for two objective function. Now two objective function, let me define in different manner. I don't want to do any minimization. I want to do maximization only. Now the scenario will be changing, no? So the parameters must be tuned. That's why I told you the parameters must be tuned based on your problem instance. So that you have to check. Yes, that is the important criteria for any application, my dear friend. So if that is solved at your end, so that you'll be able to defend the community like, yes, because of this tuning the parameter values, that I'll do. So for example, so let me take the colored photograph. Okay, colored photograph. Yes, I want to make the colored photograph in 3 different situations. Now my value is fixed, and that I want to make it more brighter, and where my black color will show quite white. So this I don't like, right? And my face should be as usual, but the background should be brighter. So now you tell me, like the passport photography opt. Now what kind of parameters have you tuned here? In the sense threshold values you are optimizing. So based on that, you'll choose the functionality of any objective function. So for any optimization problem, choosing and selecting and framing the objective function is the tricky thing. Just that's why I'm telling you. Okay, say for this problem I have framed it. Then if I could not find the solution, then definitely I could have dropped it. But it was my attempt. I can say that yes, this algorithm I have chosen for some kind of application, but it won't work. It was a failure, but it was a learning, no? Right?
Yes.
Because of this reason, yes. That's why this is up to you, my dear friend. So I cannot say.
Sir, for your problem, what is you have taken, sir, objective function? Can you show, sir?
I shown you know that
Like
yes. I have optimized. I have optimized the global search space for individual salt check first. Okay, when I consider the combination of salt chains, what I did, I consider the local search position for individual salt chain. Why? Because the number of salts have been increased, no, so that the workspace will be covered maximum. Say simple reason. One ball has been thrown. One ball has thrown in the air. Then one person given the chance to take the ball. Now, 4 persons given the chance to take the ball. Now, what is the probability? It is more, no? Yes or no?
yes, sir. Yes, sir.
Yes. So instead of staying in the middle of the ground, what I did, I have mounted the one person to one side, another person to another side, another person to another side, and I was staying in the middle. Now, based on the position thrown of the ball, if it goes to the left side, then person is already available. So that person will catch the ball. So what I did here, I have minimized the global set space here. Why? Because my population size is increasing. So this is my idea.
Yes.
As per my problem. Getting?
Yes.
Yeah,
Yes.
good
Yes.
question. Fine.
Thank you, sir.
Hope your purpose will be solved. Okay, guys, then the time is exceeding. Then we'll meet tomorrow. If you really like my lecture, please join with me so that we'll come up with a different solution for different problem tomorrow. Fine then.
Hello, sir.
Yeah, hello.
Hello. Sir,
Hello.
I would like to know the future scope. Hello.
Yeah, please.
Hello.
Please
Yeah.
tell me.
Sir, I would like to know the because I would like to know the future scope of self algorithm in medical domain, sir.
Medical domain features. I'll tell you tomorrow. Okay, why? Because I have not
Yes,
tried.
sir. Yes,
I
sir.
have not.
Yes,
I
sir.
have not,
Yes, sir. Yes,
I
sir.
have not tried with medical background. Okay, fine. I'm accepting.
Okay, sir. Yes, sir.
Okay.
Yeah, yes, sir. Thank you very much.
Thank you. I'll tell you tomorrow. Don't worry. Okay, then. Bye, bye, guys. Then we'll meet tomorrow.
Thank you very much, sir.
Yeah. Thank you.
Thank you, sir. Thank you for your valuable talk, sir. All the participants, please take the lunch break. We will join back again at 2:10 a.m. 2:10 p.m. The next topic is on optimization using genetic algorithm for data analytics. Thank you all participants. Thank you, sir.